Warm greetings and good afternoon, dear friends and students. Today, I am going to cover a video lecture on the problem solving in the case of thin cylindrical shell. Already I have defined about the thin cylinders and thin spherical shell. So here we are going to solve the problem in the case of thin spherical shells, which is having the internal fluid pressure of 10 Newton per square millimeter and of diameter 500 mm or 50 centimeter, and is having a allowable stress in the material of the spherical shell is 100 Newton per square millimeter, and the Poisson ratio is 0.25, and the Young's modulus of the material is 2 into 10 power 5 MPa. So here you have to find whatever the minimum thickness required for this thin spherical shell, and what will be the maximum shear stress, and what will be the hoop stress and longitudinal stress. So here we know that the case of thin cylindrical shell, the hoop stress is PD by 2T and the longitudinal stress is PD by 4T. But in the case of thin spherical shell, the hoop stress and the longitudinal stress will be equal. That is, therefore, F1 is equal to F2 is equal to PD by 4T. So it is nothing but half of the hoop stress in the case of thin cylindrical shell. So here our aim is to find first what is the minimum thickness required. You know that the maximum stress, either hoop stress and longitudinal stress, which is the same value, PD by 4T here. So you substitute the values, right? The only unknown is the thickness of the shell, T. So therefore, T should be greater than or equal to PD by 2F, where F is the allowable or the safe stress in the case of thin spherical shell. We are substituting the value of the corresponding value. Here P is equal to 10 Newton per square millimeter into the diameter is 500 mm divided by 4 into F. F is here 100. So after simplifying it, we are getting the thickness should be greater than or equal to 12.5 mm. So I am taking the thickness is 15 mm because in the market you will get 15 mm, not 12.5 mm. So I am taking a thickness of 15 mm. The requirement is 12.5. It is greater than 12.5 mm. So 15 mm is the thickness required. Now what about the hoop stress and the longitudinal stress? Here both are same. So therefore F1 is equal to F2 is equal to PD by 4T. So it is equal to P is equal to 10 into 500 divided by 4 into 15. So you are getting around 8.67 Newton per square millimeter. So the maximum hoop stress or the longitudinal stress here is the same. It is 8.67 Newton per square millimeter. But the allowable stress is 100 Newton per square millimeter. So the available, that is in the case of the predicted value, is only 8.67. So it is more safe. So what about the maximum shear stress in the case of thin spherical shell? So that is equal to F1 minus F2 divided by 2. So here F1 and F2 are same. So therefore, whatever the values you are getting, right? F1 is equal to F2. So therefore, F1 minus F1 divided by 2. What will happen? 0 by 2. So it is 0. So that means wherever you take the section, the case of thin spherical shell, there is no shear stress at all. So that is the specialty of thin spherical shell compared to thin cylindrical shell. But in the case of thin cylindrical shell, so definitely you will get the maximum shear stress. But here, in the case of thin spherical shell, there is no shear stress at anywhere in the cross section of the thin spherical shell. So that is having more advantages compared to thin cylindrical shell. So it will have a more pressure and also the allowable stress is more, but you will get the thickness is very small compared to the thin cylindrical shell. So that is called as the merits of or advantages of the thin spherical shell in the case of thin cylindrical shell. So The thin spherical shell is always more economical than thin cylindrical shell. So thank you very much for patient listening. God bless. வாழ்க வையகம், வாழ்க வளமுடன்.